Hello. Okay, so today we have a very big work. It is building the decanomial. And this is a work that we would do in the classroom with the colored bead bars, like the entire set. And there's 55 of each color that we would use. So this is a big work. It takes a long time. It's not a work that you can get done in one setting, even if you were in the classroom and you were using the actual beads. Um, it takes a really long time. So I first just want to like impart that and tell you that this is going to be a work that you're not going to finish all in one setting. Um, you could try, but you might be pretty tired when you're finished. So it's okay to pause, do a little bit of this work in a day. Seesaw has that option that you can when you click add your response and you can go in and you can do however much you want. And then you can click the orange draft button and it'll save it and then you can come back to it later. Only click the green check mark when you're completely done and you want to turn it in to me. But this is an extra work. This is kind of like, if you were in the classroom, this would be like a work that you could come to every day and work on it. We don't have a specific due date. So I just want you to get that. Like, work on it this week, next week, even if you come back after the winter break and you're still working on it, it's okay. Because I want you guys to take the time and build these beautiful arrays and write your multiplication and just kind of again it's more practice and that internalization of seeing it and writing the correct way of the multiplication problem, and then you're learning your multiplication facts as you do this. So it's a really cool work. So I've started off here. This is building the decanomial. And normally like we would do this on a mat and we would have it all together, like the ones in a column, the twos in a column. But because, we are virtual and this is Seesaw and we only have like basically this one page of space, I have taken it and each page is, a different multiple can. There's your twos, threes, fours, fives, sixes, sevens, eights, nines, and tens. And I've just kind of put them all over here in a clump, one on top of each other. So I've started building this over here with the ones. And as you can see, like in the classroom, these beads would actually be touching or as close to touching as we could like make it. But just because of how it's made, you can see there's kind of like this white square field around each bead. And so we can't make it touch because it starts to cover up the other beads. So there will look like this little space in between, and that's okay. We still get the idea. And as I'm doing this, we can be writing our multiplication facts. So this here, we have one group of one, or 1 times 1, which equals 1. I actually like the size of that, so I'm going to duplicate that. And then here I have 2 groups of 1, which shows I have 2 beads. So 1 times 2. My multiplicand is that first number. So I'm making different groups of 1. So that first number will always be 1. The multiplier is how many groups. So here's 2 groups of 1 equals 2. Again, I like that size. So I have 3 groups of 1, which equals 3. 4 groups of 1 equals 4. And 5 groups of 1 equals 5. And I can keep going. So normally this would be on a mat and it would all be one on top of each other, but for the sake of space, now we have to make another column of 1s. So I'm moving 6 1s over here to make my 6 groups of 1. 5 and 6. 1 times 6 equals 6. And this is when we're multiplying by 1, this is actually what we call the identity property of multiplication, because any number we multiply by 1 will be that number. So we call it identity property. And one way I like to kind of remember it is like, if I multiply Brenda times 1, it is going to equal Brenda. Huh. So, okay. So now we need 7 groups of 1. All right. 1 times 7 equals 7. And when I click out of it, then that's when I can like change the size of this. Just FYI. All right. Now I have 8. Five, 6, 7, 8. Click out of it, and then I can make it smaller. Took me a minute to playing around to figure that out. Put that right there. Now I'm ready for 9. 2, 3, 4, 5, 6, 7, 8, 9. 1 times 9 equals 9. And last one, going to be my group of 10. I might have made extra, so I can delete from here. 3, 4. Gotta move these out of the way. 4, 5, 6, 7, 8. 9, 10. Well, look at that. Exactly the amount. I was making this and I was sometimes losing count. So if you come across one and you have 1 or 2 extra beads, that's probably because it's my mistake. All right. And 1 times 10 equals 10. So we have completed our multiplicand of 1. All right. And if you would like to take this a step further and draw this on your paper with like a red colored pencil and make your 1 group of 1 and right next to it, 1 times 1 equals 1. Your 2 groups of 1, 1 times 2 equals 2. I absolutely encourage you to do that. That will just be further practice. And I would have you do that in the classroom as well. So that took me, I don't know, 5-ish minutes or so. Maybe I want to do another one for the day and then I could save my draft and go on. I will show you, let's do a bigger one like the 6s. So here we have one group of 6. And we write that like that. Our multiplication comes first. Our group is that second number. 6 times 1 equals 6. One group of 6. And I can just put it right there next to it. Now I want to make 2 groups of 6. Get it as close as I can. And that equals 12. We know that anything times 2 is a double number, so I know that 6 plus 6 is 12. So 6 times 2 equals 12. Three groups of 6. Now, if I'm not sure, so we're adding 6 to each one of these products. So 12 plus 6, if I wanted to do it that way, or I can, of course, count my beads because they're right there. And it might be kind of difficult to count, so you might want to use this pencil, and then you can like kind of click on it. So we have 6, 7, 8, 9, 10, 11, or what am I saying? Sorry. There was 12, 13, 14, 15, 16, 17, 18. Okay, so there's 18 there. And 18. All right. Now I want to do 4 groups of 6. But like some of these I can get closer than others, maybe not. 4. Yep, there's our 4. Okay, so 4 groups of 6. So again, if I'm not sure, so maybe you can also, this is an opportunity to skip count by 6s. So we have 6, 12, 18, 19, 20, 21, 22, 23, 24. So 6 times 4, 4 groups of 6 equals 24. All right. Now we're ready for 5 groups of 6. Okay. We have 6, 12, 18, 24, 25, 26, 27, 28, 29, 30. Now, if you miscount and like, let's say I counted and I got 29, you might like realize like, oh, I shouldn't be, because 6 is an even number and we're skip counting, all of our answers will be even numbers. So if you were counting and you got 29 or 31, then you kind of know like, oops, that's an odd number. I must have miscounted. Just an FYI. So 5 groups of 6 equals 30. And there we are. Okay, now I want to point out, I may not build this whole thing, but I definitely want to point out 6 groups of 6. So there's 3, 4, 5, 6. Now, unfortunately, because of the nature of this, because I can't be touching it, this takes away from the shape. It should make a square shape because our multiplicand and our multiplier are the same. So we have 6 rows and 6 columns. So we kind of lose the shape of that. But 6 times 6 is what we call a square number because yes, it does make a shape because there are equal numbers of rows and columns. So all of our numbers that are multiplied by itself are called square numbers. So back here on 1, on our ones, our square number was actually the first one, 1 times 1. For our 2s, it would be 2 times 2. For our 3s, it would be 3 times 3, and so on. And again, just, I know the shape is actually a rectangle, but that's because of the space that we have to leave in between. So you may want to, like, as a challenge for yourself, once you go through and you complete all these, you on a separate sheet of paper, if you want to like list all your square numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so on. Okay? All right. So I could keep going through here and do 7 groups of 6, 8 groups of 6, 9 groups of 6, and then 10 groups of 6. But I'm going to stop there because I think you guys get the idea. So again, remember, this is not going to probably be something you get done in a day unless you're super ambitious. I want this to be a work that you enjoy and you take your time with and not just trying to like check off a box, okay? Really want us building and learning our arrays, our multiplication, facts, and yeah, so enjoy, and I will see you later.